This is going to be the last concept we're going to cover for the year. We're going to try to relate electric current to chemical reactions. And electric current, all that is the amount of charge delivered per unit time. And because charge is measured in coulombs and time is measured in seconds, the units of electric current are coulombs per second. Now we give coulombs per second a special unit of its own. We call it the amp or the ampere. It's amp for short, and that is given the symbol capital A. There's a few more things that we can use that are going to help us in addition to these definitions, some things that we already know that's going to help us relate electric current to chemistry. The first is you should recognize that every electron, so a single electron, carries 1.6 times 10 to the negative 19 coulombs. And we also should remember that 1 mole of electrons carries with it 6.02 times 10 to the 23rd electrons. Faraday's constant is also useful in this idea of relating electric current to chemical reactions. Remember, Faraday's constant is 96,485 coulombs of charge for every mole of electrons. We're going to apply electric current to the problem of electrolysis of water. Well, what is the electrolysis of water? Well, during the electrolysis of water, you just take some water and you add an electrolyte to it, like salt or something, and then you run electric current through two electrodes that are placed in the water. So electrons get pumped from the anode to the cathode, and they have to get pumped because the overall reaction is non-spontaneous. And then at the anode, you get this reaction. So you get two waters going to oxygen gas plus 4 protons plus 4 electrons, and the cell half reaction is negative 1.23 volts. The electrons from the oxidation of water are pumped across the electrodes to the cathode where reduction occurs. And the reaction that occurs at the cathode is water gets reduced to hydrogen gas and 4 hydroxide ions, and the half reaction for that cell potential is negative 0.83 volts. Now if I add these two together, we can see what overall is going on during the electrolysis of water. My 4 electrons cancel. On this side I have 6 water molecules, and those 6 water molecules will be going to oxygen gas, 2 moles of hydrogen gas, 4 protons, and 4 hydroxide ions. And the overall cell potential for this is going to be a negative 2.06 volts. So it's not spontaneous. Water does not spontaneously split into hydrogen gas and oxygen gas. Now notice I can take these two ions, so 4H plus and 4 hydroxide, that's going to immediately form 4 waters. So that means I can take these 6 waters in and these 4 waters out, and the balance of that is 2 waters at the start goes to oxygen gas and hydrogen gas. And we can imagine running a current through these two electrodes of 0.445 amps for 45 minutes. And if I do that, if I run a current of 0.445 amps that I can measure across these two electrodes for a total of 45 minutes, how many grams of oxygen gas might I produce in the process? That's an interesting question. And what's interesting about it is we can relate the electric current, unit of electricity, dynamic unit of electricity, to chemistry. How many grams of oxygen would be produced? So let's try it. I'll start here with 0.445 amps, which is coulombs for every second. I'm going to figure out how many total coulombs of charge were delivered by taking this and saying, well, we ran the reaction for 45 minutes, Of course, minutes and seconds don't talk, so I better make sure to do a conversion here. I know that 1 minute, well, that's equal to 60 seconds. And if I do that, these units all cancel each other. Okay, so let's figure out how many coulombs of charge would be delivered if I ran 0.445 amps for 45 minutes. So that's going to be 0.445 times 45 times 60. 1201, we'll make it 1202. Coulombs of charge delivered. Now, if we deliver this many coulombs of charge, let's figure out how many grams of oxygen could be produced. So I'll start here with 1202 coulombs. And I happen to know that there are 96,485 coulombs for every mole of electrons. I can also look up here and I can say, look at that. 4 moles of electrons relates to 1 mole of oxygen. So let's see, 4 moles of electrons is going to relate to the production of 1 mole of O2. And then finally, we recognize that 1 mole of O2, that's 32 grams of O2. 16 plus 16. Do a calculation here. 1202 divided by 96,485. Divide that by 4. Times that by 32. And we get, basically, 0.1 grams of oxygen gas if we try to electrolyze water at 0.445 amps for 45 minutes.